Quadratic functions are the topic of interest today. We're going to be talking about quadratic functions. Those are functions of the form ax squared plus bx plus c. A, b, and c are real numbers, and c is not equal to 0. And of course, a is not equal to 0. If a were equal to 0, then we would have just a linear function because this term here would wipe out. Okay. We're going to sketch these quadratic functions, and these are the basics of sketching. We're going to find the vertex. We are going to find the y-intercept, the x-intercept, and then we're going to use the leading coefficient test to give us an idea of what it will look like. Quadratic functions are going to be of a parabolic shape, meaning that they will look like this. And that is if our leading coefficient is positive, that's our a. Or they will look like this. And if our leading coefficient is negative, or a is less than 0, that's what that means, then they will be a parabola going down. And this I will describe as a parabola going up. Here's our first function we're going to look at today, x squared minus 2x minus 3. Our leading coefficient is a 1. A is greater than 0, so it's a parabola going up. You could graph this in your graphing calculator. Just plug this into y equals and then hit graph. Our vertex, that is going to be another code word for vertex, would be either minimum or maximum. For this particular parabola, our vertex is a minimum. Our vertex is at, looks like x is 1 and y is negative 4. We're going to find that algebraically in just a minute, but I just want to look at the graph, find these points, and then we'll figure out how you find them algebraically. The y-intercept right here, and that would be at x is 0, y is negative 3. The x-intercepts, we have one here, and we have one here. These occur at negative 1, 0, and we have another one at 1, 2, 3, 0. Alright, now we're going to go back and find these numbers algebraically. We're going to find these points, and then we're going to discuss how you would plot this graph by hand. When asked for the vertex, remember that if it's a parabola going up, the vertex is a minimum value. If it's a parabola going down, the vertex is a maximum. Alright, let's find all these points algebraically. Here's our function, x squared minus 2x minus 3. Our a is 1, our b is negative 2, and our c is negative 3. Let's find the vertex. What this formula tells us to do is to find the x value, we take in place negative b over 2a. So let's do that. Our x value would be equal to negative b, so that's a negative 2 over 2 times 1, which is 2. So our x value is 1. In order to get the y value, what this says is take your function and in place of x, put what you got for x. And we got a 1, so I would place that into the function, and I would get that y equals 1 squared, which is 1, minus 2 times 1, that would be 2, minus 3, this would equal negative 4. So our vertex for this function would be at 1, negative 4, which was what we observed on our graph, which I'll pull up in just a minute. Our y-intercept, we substitute in a 0 for x. So in order to find the y-intercept, we'll do that right here. Plug in a 0 for x. Y equals 0 squared, which is 0, minus 2 times 0, that's 0, minus 3. So our y-intercept occurs at negative 3. So for our y-intercept, we get x is 0, y is negative 3. Alright, now for the x-intercepts, which are harder to find. Of course, we substitute 0 for y, and then we solve for x. Now, If it's a nice one, it'll factor, and we can read those off very easily. If not, you'll have to use the quadratic formula. So we have, I believe if you factor this, you'll get x minus 3, x plus 1. And so my x-intercepts occur at 3 and negative 1. So writing those down in point form, x-intercepts are 3, 0, and negative 1, 0. And that's how I'll get those points. Now let's look at our graph again. And these are the exact points that we calculated. Now this doesn't happen very often, but occasionally you'll get a quadratic that's given to you in standard form. I've written down this exact same equation in standard form, and when it's given in this format, you can read off the vertex. This will be your x-coordinate point, and the standard form actually looks like x minus h quantity squared plus k. So you'll have to remember to watch that sign on your h, because x minus h is standard, so this would happen at 1, and k would be negative 4, which is what we got. This is only if they happen to give it to you in standard form. If you want to, you can put your equation in standard form by completing the square to find the vertex. Completing the square was discussed in the quadratic section previously. You could complete the square, put this in standard form, and read off the vertex. To me, it's easier just solving for the vertex using the minus b over 2a, but either way is valid, and you can do either. So I'll just discuss them because you could do it that way. Alright, we'll look at another one, just a slight variation of the other. If you'll notice, the leading coefficient on this quadratic function is a negative 1. That means we will have a parabola going down. Here's his vertex. In working the word problems, they'll ask you for minimum or maximum, and all they're asking you to do is find the vertex. The vertex occurs at x equal to 1, and the y value there, the maximum value, is 4. For the y-intercept, he's right here, and he would be occurring at 0 for x and 3 for y. My x-intercepts, one here and one there. Those particular points are negative 1, 0 and 3, 0. Alright, we're going to look at how to get these particular points algebraically in just a second. The standard form for this particular function, I've completed the square on this one, and what it would look like in standard form is negative, because our leading coefficient is negative, x minus 1 quantity squared plus 4. And notice that I can read the vertex right off. There's my h, there's my k. The vertex happens at 1, 4. Notice that change in sign on this h once again if you're using standard form, and choose to use that method in order to find your vertex. Alright, finding these points algebraically, in order to find the x, I would do, here's my a, b, and c. I've written them out up here at the top. My b is 2, so it would be negative a 2 all over 2 times a. So that would be 2 times a negative 1, which would be a negative 2. My x-coordinate then would be a 1. Plugging that back into my function in order to find my y value, I would get negative and then 1 squared, which would be 1, plus 2 times 1, which is 2, plus 3. And this y value would then be 4, which was what we observed on our graph. The vertex then is at the point 1, 4. There's our algebraic calculation for vertex, also known as the minimum or maximum value. For y-intercept, what I do is I let x be equal to 0, and notice if I plug a 0 into each of these x's, I get that y equals negative 0 squared, which is 0, plus 2 times 0, which is 0, plus 3, and my y value is 3. So my y-intercept is at 0, 3. My x-intercept, so I let y be equal to 0, and then I'll try and factor this thing, hopefully. So I'll have negative x squared plus 2x plus 3. And if you factor this thing, you will end up with 2 x plus 1 and negative x plus 3 or 3 minus x, whichever you choose. However you want to factor it, so that you will get the x-intercepts to be equal to negative 1 and 3. My x-intercepts then would be at negative 1, 0 and 3, 0. Using the leading coefficient test, since my a is less than 0, or is negative, this would be a parabola going down, which we observed on our graph.